Welcome friends. In this video I will solve some problems related to kinetics of particles. So let us start. Sample problem number 2. One problem we have already solved in the previous video. So this is your problem. There are two blocks A and B, and one block is resting on the surface while another block is hanging with the help of the cord, and the surfaces are frictionless, and this pulley is assumed to be of negligible mass, and we have to determine the acceleration of each block and the tension in the cord. So what is the solution strategy? First we will write the kinematic relationships because the motion are dependent. So we write that relationship, then we write the equation of motions with the help of free body diagram and kinetic diagram, and then we will combine all the equations and solve for unknowns. Our solution. So first we will write the kinematic relationship for the dependent motion. So as you can see, this YB should be half of XA, means the distance covered by YB should remain half of the distance covered by this block A, which is XA. Okay, and you can differentiate this equation twice, so you will get the relation. Acceleration of block B will be half of the acceleration of block A. So this is first equation. Next, what we will do, we will draw the diagrams, free body diagram and kinetic diagram, FBD and KD for block A, and then we will write the equation of motion. Okay, so in the x direction we have the force MA, sorry, the force is T1, and on the right side we have the inertial force, that is MA into AA. So here T1 is unknown and we know the mass of the block 100 kg and acceleration. So this is our another equation. Then we will write for this block B, these are the FBD and KD. So here we are having the motion in y direction. Okay, so in the y direction there are two forces, this weight force and tension force, and on the RHS we will be having mass into acceleration. So this is another equation, and now we will write the relationship for this pulley. So this pulley is negligible mass, so we will not consider the weight of this pulley. So the only relationship here is of the tensions, that is we are having T2 minus 2T1 is equal to 0. Now these are your equations. This is the equation number 1, this is the equation number 2, 3 and 4. Okay. Now the next step in the solution is to combine all these equations and solve for the unknowns. Okay. So from this first equation you can get T1, then from another equation you will get T2. Okay. So after solving from all these equations, the answers comes out to be acceleration of block A is 8.4 meter per second square, and we know the acceleration of B is half of this, so this is 4.2 meter per second square. T1 comes out to be 840 Newton, and T2 is twice of T1, so that is comes out to be 1680 Newton. So this is the complete solution of this problem. Okay. Now we will do another problem. So this is your problem. The 12-pound block B. This block start from rest, and this block slide on this block, which is another block of this shape. Rather it is a wedge A of 30 pound, Okay, and this is supported by the horizontal surface. So we have to neglect the friction, then we will determine the acceleration of the wedge. So we have to find the acceleration of this and then acceleration of the block relative to the wedge. Okay, so what will be our solution strategy? So since the block is constrained to move downward, so therefore their motion are dependent. Okay, both these motions are dependent because it is already given that this block will move downward. Okay, so accordingly you will have to write your relations. Okay, so for that you should express the acceleration of block as the acceleration of wedge plus the acceleration of the block relative to the wedge. Acceleration of this plus the acceleration of B relative to this. That will be the acceleration of block B. Okay. Then next step is to write the equations and then solve for the unknowns. Now we will do the solution. So as we already know, the block is constrained to slide down, and for block to slide down we have this relationship. Acceleration of block B should be equal to acceleration of block A plus acceleration of block B with respect to A. Relative acceleration of block B with respect to block A. For this equation you got, then you will draw the free body and KD for this wedge. So in the wedge we are having three forces, two reactions, N1 and N2, and then weight. And this is the kinematic diagram. So what we can do, we can equate the forces with MA. So we are having in the x direction there are only this force N1 sine 30. So this is one equation. Okay. Now another equation you can write for this block B. These are the free body diagram and kinetic diagram for this block B. So again we can write the summation of x is equal to mbax. Okay, and this acceleration is this. It contains two components. Okay, so we can write here, while the forces in the x direction is only this weight, the component of weight, so wb sine 30 degrees. So this is another equation. And one more equation we can write in the y direction. So in the y direction we have this reaction N1 plus one component of weight. Okay, and in the y direction you are having the y component of acceleration. Okay, so now we are having these equations 1, 2, 3 and 4. So from these four equations we can solve for unknowns. So after solving, so you can try yourself. The answer comes out to be acceleration A is equal to 5.07 feet per second square. So these are simply the arithmetic equations which you can easily solve. And we can also calculate the acceleration of block B relative to A from equation 1, and then it comes out to be 20.5 feet per second square. Now we will do one more problem. So again, this is the problem of connected motion, dependent motion. The two blocks shown are originally at rest. So these blocks are originally at rest, neglecting the masses of the pulleys. Okay, and the effect of friction in the pulleys and between block A and the horizontal surface determine the acceleration of each block and the tension in the cable. So these two are the unknowns. So let us see what is the solution strategy. So that will remain same. First we will write any kinematic relationship for the dependent motion. Then we will draw the FBD and KD. And next step is to write the equations and then solve for the unknowns. So you have to follow these steps throughout any problem you are doing. So first we write the equation for the dependent motion. Suppose we have considered this point as the origin, okay? So these are our y distances and this is our x distance, okay? So we know that for dependent motion, length of cable should remain same. So the length of cable is XA plus YB, 1, 2, 3. 3 times YB plus this length. So we call this length as constant. Okay. So XA plus 3YB plus constant is equal to L. So this is one relationship. And what you can do, you can differentiate this twice. Then you will get the VA plus 3VB is equal to 0 and AA plus 3AB is equal to 0. So this is one equation. Next step, the free body diagram and KD for each block. So this is for block A. So these are the forces which are acting on the block A. And this is the mass into acceleration, means kinetic diagram of the block. And this is for block B. In the block B, again we are having this weight force and tension force, and this is the kinematic diagram. So from these two FBD and KDs, we can write the equation of motion for each block. So for this, we are having the equation summation of Fx is equal to MAAA. So in the x direction, we are having T. So one equation is this, and from the block B, the equation is the summation of Fy is equal to MBAV. So in the y direction, we are having weight plus tension. So WB minus 3T is equal to this. So now we are having three equations and three unknowns, and all these equations are simply arithmetic equations. So you can easily solve them and you can get the answers. So just pause the video here, solve yourself. So the answer comes out to be T is equal to 74.8 Newton and acceleration is 2.49 meter per second square. Now a concept quiz for you. Consider these three figures 1, 2 and 3. The three systems are released from rest. So we are releasing all the three systems from rest. So which one is having higher acceleration? Just pause the video and think, and the answer is C. So this is having the highest acceleration, then the 1, and then the this 3. So this is for today's video. Thanks for watching. Thanks. Have a nice day.